Hi Spring fans, in this installment of Spring Tips, we're going to look at OAuth, in particular how to build an OAuth server using Spring Security OAuth. Now, the use case for OAuth might elude some people, and the reason is because there are so many use cases for it, and I feel like a lot of people probably look into it and think, well, that's not for me, that's entirely too complicated, or that does something different. So what I want to do is just ever so briefly sort of lay down some of the use cases that motivate the use of OAuth, and then look at how to stand up an OAuth authorization service using Spring Security OAuth today. We're going to ignore for now the discussion of how to actually consume that OAuth service from the perspective of a client. That I think will be a topic for another video, another time. Naturally, we'll test that our services works as we expect, but we're not going to build a full-on Spring based application to consume that OAuth support. Okay. All right. So when people, as people are building more and more microservices, as they're building more and more systems that are connected to the open web, they're discovering that these applications, these kinds of workloads, are more and more often being consumed by any number of different kinds of clients. And this is where a technology like OAuth comes into handy. For you see, it is no longer enough for a client, or rather a developer, to think about the world in terms of just the user context, the person that is making the request of a service, because now you've got different clients, right? Now you have to think about both who is making the request and on what client that user is making the request. And to give you a couple of examples, most of us, I'm sure, although I confess not me, but a lot of people use Facebook, right? And Facebook is a social network on which you can spam your friends and family and loved ones, right? And the thing that has become very ubiquitous is this sign in with Facebook mechanism, right? You can find third-party websites that allow you to click on a button, and then in so doing it redirects you to facebook.com, prompts you to authorize Facebook to do whatever it wants to do, right? You can spam all your friends and loved ones and so on Facebook, and then it redirects back to the third-party website, and when it redirects back, that website now has what it needs to be able to make requests on your behalf from that third-party service, right? In this example, the third-party website is a client, right? The client is the third-party website acting on your behalf. It is a client that is acting on behalf of, in my case, Josh, right? It's not Josh. It's not like I'm driving the request, or I might be driving the request, but the point is they can drive the request now as well. It could be something that's running in sort of back office mode. It could be headless. It could be whatever, but they're doing it on my behalf. So in this case, there's the authorization service, which is the endpoint that we talked to get the token and to sort of interact and get it an authorization code or a token. There's the resource server, which is the API, the Facebook REST API that contains your friend graph and your profile information and whatever else they have in their API. That's a resource that is protected. You have to, in order to be able to access information on that in that API, you have to have a valid token as created by the authorization service. And then finally, we have the client, and the client is, of course, the third-party website acting on behalf of you, the user, right? So you've got these four things in play, and this is a common example. This is a third-party website. Facebook doesn't want that third-party website having access to your password, and you probably don't want that third-party website accessing your password either, right? So there's a little bit of indirection that happens in this particular instance. What happens is the third-party website makes a request to Facebook for an authorization code. The Facebook then prompts you to log in if you're not already logged in, and then it prompts you to confer the privileges it's asking for upon the client. At which point, if you accept, it redirects back with the authorization code to your third-party client, and then the client uses that authorization code to get what's called an access token, which it then can use to make subsequent calls to the Facebook API, the resource that's been protected. This is one kind of flow. It's a very common flow. You'll see this, I think, the most often. This is the flow that web applications acting on behalf of third-party clients and services and APIs acting on your behalf will use. It's the kind of flow that browser applications will use nowadays, new browser applications. Historically, there's another flow called the Implicit Grant, which skipped the authorization code, or rather, sorry, it skipped the requirement to send what's called a client secret, and that made it easier for browsers to get access to a token. But I think it's, and I could be wrong, but as far as I've seen, it's been sort of superseded by the recommendation that that most people use the authorization code flow and simply omit a client credential, a secret rather, a client secret. There's that flow. There's another flow called the password flow, right? The password grant. And in this case, instead of having a third-party client make a call on your behalf, but by first being redirected to the trusted authorization service, the Facebook website where they then prompt you to log in and so on. In this case, a client submits or transmits your username and password on your behalf directly to the authorization service, right? So this is a common example in a native application, and in particular, this is something that that you would hope would only be done by the company that builds the API in the first place. So Facebook.app, the iOS application as developed by the folks at Facebook would be something that is developed with a password grant. In this case, it makes no sense for the native Facebook application on iOS to redirect you to facebook.com asking for permission for Facebook.app to access your Facebook information on facebook.com, right? Of course they can access your information, and of course there's no real worry about them having or transmitting your password since they're Facebook, right? They already have your password. It's not like they're going to run away and do something malicious with your password. If it was a third-party website, then there might be that risk, right? It might be a third-party client that you may not necessarily trust. And in this case, it's very important that you keep your password out of their hands, because you want that ultimate veto, right? So long as they don't have your password, you can always log in to to Facebook or some other third-party website, Twitter, GitHub, whatever, and say, I want to reject this particular application because it's performing or behaving maliciously with my information. And then so that's those are the two very common ones: password grant and the authorization code grant. There's a fourth grant, and we talked about the implicit grant. There's a fourth grant, and that is the client credentials grant. And in this case, where the first three flows assume a client and a user context, right? It's a client acting on behalf of Josh or Jane or somebody else, right? There's a human being in there somewhere. With the client credentials grant, you have this idea of a client without a user context. And in this case, this is the kind of flow that back office services might use. Things that aren't driven by human beings. There's no particular user context associated with it, but you want the benefits of OAuth. You want the protection that you get by using OAuth, and it's a common workflow, right? In this case, it's a client that has to authenticate. So clients in the OAuth world have usernames and passwords, right? They have client IDs and client secrets, right? This is an ID and a password. And then users also have usernames and passwords. In the OAuth world, these two things are separate concepts. And the reason for this is as XML creator Tim Bray once famously described, usernames and passwords don't scale, not on the open web, right? As we've just looked at, as we've just illustrated, there's a lot of different ideas for clients, a lot of different notions of clients. It depends on where you are and what you're doing, but if you go to any brand out there that you can think of, they probably have at least an iPhone application, an Android experience as well, and a HTML5 browser-based experience, right? So that's at least 3 different clients. Gone are the days when we could presumptively assume that they will have just one experience, one HTML desktop browser-based experience, right? And as often as not, this is not all of it. It's just the beginning, right? I mean, there's certainly a number of other kinds of experiences that startups these days or companies and brands are building. So there's iPhone, of course. There's iPad. There's different tablet devices. These may be entirely different clients. They may be branches or forks on existing clients. There are all sorts of other kinds of clients out there as well. Cars nowadays have SDKs, which implies that there are now cars that talk to services, and those cars have IP addresses. There are refrigerators and microwaves are all connected, right? With the Internet of Things, this is entirely real possibility. If you go to Singapore, the roads in Singapore are connected to a grid. They have sensor data that gets fed into a grid, and that sensor data is used to do processing and then to do predictive traffic shaping, analytics, and then traffic shaping, right? So, in essence, the roads have an IP address, right? They are clients to some sort of service. There are human beings on the planet walking around with organs that are connected to the internet, and they have IP addresses. So really, the sky is the limit these days in terms of what qualifies as a client, and not all clients are capable of the same kind of guarantees. Not all clients should be given the same entitlements, and not all clients are as secure, right? So OAuth is a specification. It's a authorization delegation specification that's purpose-built for this sort of jungle-like environment for different kinds of clients. And this is a great fit for the world of microservices, right? We want to be able to bring in lots of different clients, and we want to be able to talk to them and welcome them into the system without having to change every single service for each one of these clients. So if you have a microservice system, you're going to secure them using Spring Cloud Security, and these services become resource services, right? These are resources that Spring Cloud Security can declaratively secure for you, and we'll talk about that in another installment. But the point is, you can tell these different services to reject requests that are coming from some sort of client without a valid token. But all clients can, through one of these different grant types, one of these different flows, they can ultimately obtain a token. So that means that it's easy to scale out the clients that are able to talk to your services without having to change all of your services. So what we want to do is we want to build an authorization service today. Now, what I said earlier is worth restating. OAuth is not a solution unto itself, right? It's an authorization delegation specification, and that is to say, it doesn't handle the question. It doesn't provide a solution for the question, is this user who she or he says she or he is, right? It doesn't handle the question, given a username and password, is that correct? It instead delegates that particular check to some other system, and it can really be almost anything under the sun. That's the whole point, right? The Auth specification talks very specifically about SAML, for example, and talks about integration with other technologies. So the point is, you need to plug in that mechanism. Well, of course, Spring Security OAuth is built on Spring Security, which in turn integrates with everything under the sun. It has the ability to answer that question. So we need to first answer that question, which is, how does my OAuth service know, given a username and password, whether that user is correct or not, right? So we need to provide it with some way of answering that question. And then finally, we need to configure the clients and their permissions, and marry these two together in our configuration for Spring Security OAuth itself. So let's build an authorization server here. Okay, I'm going to say auth service, and I'm going to use the Spring Security OAuth support there. I'm going to use Spring Boot's support for building web applications. We're going to answer our question in terms, we're going to answer questions about the users by pointing Spring Security OAuth to a repository, to a DAO-based authentication manager. And we're not going to actually have to do all that much to get that working, but the point is we need some sort of DAO, data access object, that can talk to a database and then, given a username and password, perform a query and return a response. So we're going to use JPA, and we're going to use H2 rather. H2 is just an in-memory embedded SQL database that'll make it easy for us to prototype. So let's hit generate and spin this up, and we'll extract this, open, okay, and open that up as well. All right. So we have a few things that we need to do. We need to first provide some configuration. So I want this to, I'm going to call this the auth service, right? And normally in a Spring Cloud sort of architecture, you'd have a config server, and you could just point this to your config server. But as I don't have that set up here, and I don't really care to go out of my way to do that, I'm just going to copy some existing values that I have laying around for this configuration. Okay, so we're going to say that we want to allow logging to run on the debug level. That's convenient. We don't need that. We want to run the code on port 9191. Again, no particular reason. It's just something I've done before, and it's convention. We want to run it under a certain context path. So we're going to make all requests to the authorization server start with /UAA. Whenever anything happens, it has to go to /UAA, and then the other standard OAuth endpoints. Okay. And that's it. That's the sum of that. Now let's focus on the code here. We're going to build an authorization server, as I say, and the authorization server is going to work in terms of JPA. So in order to do that, I'm going to use Lombok, the compile time annotation processor that I neglected to include in the application when I generated the code from the Spring Initializer. And what I'm going to do is I'm going to build a simple entity, a JPA entity called an account. So I'll say class account, and the account will have an entity at entity, and I'll say at ID, at generated value, private long ID, and then I'll say that I want to have a string field for a username, yet another one for a password. I want to have another one, Boolean, that answers the question, is this count active? Right? And as we'll see later, this active Boolean will, it'll stand in for actually a fair number of different questions, 4 different questions relating to whether the account's active, whether it's valid, whether it's been locked out, that kind of stuff, right? So there's I think that is the basis of what I want to describe here. So I'm going to use Lombok to make short work of generating constructors and, all argument constructors and toString method, etc., right? Actually, toString is probably not a great idea here since we've got a password. So we'll leave that as is. And now what I want to do is I want to be able to manipulate instances of this account repository. So I'll say account repository extends JPA repository, and I'm going to say that it's a JPA repository that manipulates entities of type account whose primary key is of type long. Okay, and I need to now persist some sample usernames and passwords into the database. So I'm going to create a command line runner. This is a Spring Boot component that will, when it starts up, it'll log records to the database. It'll just write data to the database. So when Spring starts up, it's going to call the run method and give us a chance to do any kind of application initialization, which is precisely what I'm doing here. And I'm going to just create some hard-coded usernames and passwords. Again, this is a in-memory database. I'm going to need to recreate these records on demand or on startup. But of course, if you had a durable MySQL or Postgres or Oracle, whatever it is you're using, then you could just use that. Obviously, you could talk to a real database, but this is a simple demo. So let's see. We're going to create a few sample users. JLongSpring, right? That's me, my username and my password. DSire Cloud, right? The good Dr. Sire. PWeb Boot. RWinch Security, right? These are some very boring username and password combinations, and I'll say that I want to take each string and split it, so I have a username and password. Excuse me. Okay, and then I want to visit every single one of those. That's now I've got an array. So for each element in that stream, I now have an array. I have a stream of arrays with two elements in them, right? And then for each tuple, I want to say account repository .save new account, and I want to pass in the well, for now, I want to create a new constructor that only takes the username and the password and the active flag. I don't need the actual primary key, right? So there's all that. There we are. Let's see what that looks like. Okay, we're going to say tuple 0, that's the username, tuple 1 is the password, and the final one is is the account active? And for now, let's just say that everybody's active. Now, naturally, this wouldn't be the case if you were using a database. It would be it could dynamically change. It could change dynamically, in which case all of this is irrelevant, right? So that's fine. Now I'm going to write some records to the database. We've got that. I think we're okay there. What we want to do is now teach Spring Security, just Spring Security, not Spring Security OAuth, about our username and password database. And this is the kind of code that you would have written, not exactly like this. I mean, obviously you would have probably done a better job, but you would have written this kind of code, this kind of integration, this kind of glue code to make Spring Security talk to your identity provider, whatever that is, a decade ago. It's the same basic chore. What we need to do is to tell Spring Security that when it gets a request to authenticate for a username JLong, it needs to know what to do, right? At the heart of Spring Security is this concept of an authentication manager. And an authentication manager in Spring Security is a very simple interface. It says, given an authentication, try and authenticate, and in so doing, set the isAuthenticated Boolean on this authentication object to true. So set authenticated should be set to true or false, right? But you should have a result from that. The authentication manager then returns the hopefully authenticated authentication, or throws in one of a series of different exceptions, right? Disabled exception, locked exception, bad credentials exception, etc. This is a generic, very, very sort of abstract interface that works with anything, right? Really, any identity provider under the sun, anything you can think of can be made to fit or work in terms of this contract. It doesn't care whether the request for authentication is happening or is being done in terms of usernames and passwords, or a key being transmitted in the request body, or if it's being done in terms of a token. It doesn't care, right? It's very, very sort of generic, and you can implement it however you like. There is a specialization in Spring Security to support the particular specialized use case of answering the question, given a username and password, is this a valid user? And that specialization is called the User Details Service, right? So the User Details Service is a Java interface that has a very simple contract. Given a username, return a type or an implementation of the contract of the type user details, which in turn contains a collection of granted authorities. A granted authority is really just a string. It's just a wrapper around a string, and the string could be whatever it needs to be in your particular technology, right? It could be your notion of roles or scopes or permissions or granted authorities or whatever, right? They're basically entitlements, things you're allowing the client to do, right? So we have to answer that. We have to be able to provide that collection. We have to provide the password for the user and the username for the user, and we have to answer these 4 questions. Is the account expired? Not locked, or locked rather. Is the account non-expired? Are the credentials not expired? And is the account enabled? And in our case, I'm just going to answer all 4 of those questions with the same answer. Is it active? And of course, we'll say yes, right? So those should all be true. So we need to implement that. We need to implement our own user details service. There are, of course, make no mistake, there's any number of different implementations out there that'll talk to all manner of different identity providers in the back end. But for our purposes, we're just going to provide a very simple account user details service. Okay, implements user details service, and we're going to answer the question. We're going to say, when somebody asks me, given a username, whether I have a valid user details, we're going to use our newly minted account repository. Okay, so there we are. Create a constructor, and we'll move this up here. There we are. Okay, so there we go. There's our very simple husk of a service. Let's actually implement it. So account repository dot, we need a find by username, right? Passing in the username, and I want to implement this, but I'm going to use an optional, not the default user details. So I'm going to say I actually want an optional user details. Optional, actually, I want an optional account of that I can resolve by username. So in the Spring Data world, if I say I want a return value with an optional, it'll give me an optional that is either empty or it contains the record that I'm searching for in this case. So here I'm saying find me one record that has that username. So I'm going to either find it or 0, but it's not going to be, hopefully, more than 1, otherwise I'll get an exception. And so what I'm going to do is I'm going to say, okay, if that's there, let's map the account to a implementation of the user details type, a concrete implementation of which is called the user type. So I say account.username, account.password, and here I need to return those 4 questions. So I need to answer those questions rather. Account.isActive. There we are, 4 different ways. And finally, we need to return a collection of granted authorities. And I'm just going to use a very convenient little utility class in Spring Security called authority utils. I'm going to create a authority list. And these are just authorities. These are whatever you want them to be. In this case, it's just I'm going to make everybody a administrator and a user in the system. And if I do that, great. But otherwise, I need to throw an exception. Remember, the contract here for Spring Security is that either you find a valid user details, or you return, or rather you throw an exception. You do not return null. Right? That's not a valid choice here. So I'm going to say I couldn't find the username. Okay. And either way, our job is done. Right? We've done what we can to satisfy that contract. And this is, again, as I say, this is just stock standard sort of Spring Security, the kind of stuff you would have written years ago. Now, this is already pretty good. We're already, off to the races here, but we're still not done, right? We still need to teach Spring Security OAuth about what we've just done. We need to also teach Spring Security about the clients that we want to stand up. So let's create an auth service configuration, extends OAuth server, auth service configure adapter. Okay, and we need to override a few key methods here. We don't need to override the constructor, though we could. These are all no op. That is to say, they're empty. They're just for you to have callbacks. You don't have to implement them. You don't have to use them, but they're convenient. In our case, we don't want to configure the security per se, so we'll leave that as is. What we want to implement is an override is the clients and the endpoints. So this is a configuration class, and we're going to tell Spring Security OAuth that we want to create an authorization server. So there we are. And in the callback methods, we want to tell in the configure for the authorization server endpoints configure, we want to tell the Spring Security OAuth mechanism how it's supposed to delegate the username and password authentication. And of course, in this case, we're just going to delegate it to the existing Spring Security configured authentication manager, which is going to be auto-configured for us. And that's already, it's going to be available and we can inject it. So I'm going to do so. I'm going to say private final authentication manager, injecting this. I'll create a constructor, and we'll pass that in. So this dot authentication manager, and voila, right? There's our the sum total of our authentication manager, our connection, the glue that we had to write to connect these two different systems. And finally, we're left to tell Spring Security OAuth about the clients that we want to allow. So if you've ever used the Facebook OAuth APIs, and there's a developer.facebook or developer.twitter or developer.google, usually a portal, and wherein you can register arbitrary clients, right? This could be the Spring Tips Android client, or it could be your embedded sign in with Flow for Facebook or whatever. Either way, it's up to you to provide a username, or rather a client ID and a client secret, and to specify the flow that you want to have supported for your particular use case. And usually that's some sort of dynamic form that you fill in the details and then gets added to the database, possibly after somebody on the other side has eyeballed it and confirmed that it's actually a valid request or the valid sort of applicable use case. But in our case, we're just going to build a hard-coded list of clients. In fact, we're just going to build one client. But again, if you're so inclined, there's no reason you couldn't point this to a data source that's using the JDBC schema, which Spring Security OAuth provides, or you could just provide your own implementation of the client detail service contract. Again, the client detail service contract is more or less similar to what you're doing in the user detail service. You're saying here, given a client ID, return a client details, right? So you could provide your own implementation of that as well. In our case, I'm just happy to use the in-memory version and say that I want to build an HTML5 client with a secret called password, and I want to say that I support the password flow. I could support authorization code and all these other ones. It's a variadic array, so I could put multiple values here, but I'm just going to do password for now. And I'm going to say that I want the OpenID scope. In this case, that means nothing, but it's a scope that I want to see supported when I make the request. Okay. All right, so that's one client, and again, there's no reason you couldn't build, you know, an HTML5 client, an Android client, iOS client, etc., and then configure them each according to the use cases for you or your organization's clients, or indeed any arbitrary number of clients if you want to let those in as well. I think that should do it. If we run this, we should be able to make a request, send a valid request to the token endpoint, and get a valid access token reflecting what we've just done. So let's run this code. Okay, so the application is up and running on port 9191, and I'm going to use the Postman browser plugin here to simplify the task of requesting a valid token. So remember what we said, it's on 9191. It's going to make a request to 9191 UAA OAuth token. So this is the custom context path that we've provided, and this is the actual standardized OAuth endpoint that we're going to call. And when we send the request, we're going to say that we accept the application JSON, and we're going to send a authorization, a header, a basic authorization header. The authorization that we're sending are the username and password. In this case, are the client ID and the client credential, the client secret rather, that we're sending. So HTML5 and password, that does correspond to this, right? So HTML5 password, and we're going to send in the body several parameters. We're going to send the password, which is the username, the user password, the username itself, my name and password, the grant type that we're seeking to use, in this case the password grant type, which is the flow, the scope, again any arbitrary string, the client ID and the client secret. So if we make this request, we should get back, and we do by the way, an access token that we could then send to any protected service in the body. Right? We can send this request, this token, rather, using a request that looks like this. Right? Curl -h authorization bearer paste, and then some url.com foo bar. Right? So that would give you as long as that service that we're calling, as long as that resource server is configured to validate the tokens and to talk to our authorization servers, that would work. So there we go. You can now use that authorization server with any valid OAuth client. In the Spring ecosystem, Spring Cloud Security provides an OAuth client, and so does Spring Social, right? Although there is some work being done to converge the client story for both Spring Cloud Security and Spring Social. And indeed, there's even a fairly fundamental reworking of the OAuth support on the client happening as Spring Security OAuth gets moved into Spring Security proper. So we'll see that this is actually a pretty interesting space, and we'll see that that functionality is evolving fairly quickly to accommodate a lot of the new requirements of microservices these days. Now, we haven't talked in this installment about OpenID all that much, which is a sort of a standard way of connecting different kinds of applications to the specific endpoints required for to sort of work with the tokens themselves. We haven't talked about JWT, right? In this case, in this scheme, every client will need to talk to the authorization server whenever it receives a token in the request body. If your token is a self-contained, that is to say, if it has the sort of the signed value that you would otherwise get by talking to the authorization server in the body of the token itself, then it can just be unpacked in flight. You don't need to actually make that extra hop and call the authorization server. And you can use OAuth with JOT or JWT tokens. That's another very distinct possibility as well. All right, with that, thank you very much, and we'll see you next time.